Now it's time to create the proposed grading plan. So first we'll start off by creating a brand new drawing, and it of course is based on the template like we've done all semester in our class folder. Template proposed grading plan. So be sure you use that one so that you can have all of the settings that are necessary to complete this assignment. You'll save it to your U drive as specified on your handout, and I'm going to go ahead and set the XREF layers current and insert my XREF by attaching it. You can do it this way, or you can open up the XREF manager itself, and the way to do that is to click on this icon right here at this lower left arrow or lower right arrow. XREFs opens up a palette instead, and you can click on the drawing attach and navigate to the location of your XREFs. Yours will be on your U drive in the folder specified, and I can select both of these at the same time, the XX base E and the proposed. The type of overlay or reference, the type of reference will be an overlay, and we'll say OK. And if you make sure that you have an overlay specified, because if you don't, then the XREFs could get nested within each other. One thing that I'm having an issue with is the brightness of my XREF. So if I drop down my XREF panel, I can just decrease that XREF fading to 0, and now it looks normal. But I got two separate XREFs, the existing base and the proposed base. Now I'll begin importing my existing ground surface by XML. So insert land XML, S drive under our class, data folder, existing ground surface. I'll say OK. It brings in the surface. It's just an outer edge boundary, so I need to change the style for that by clicking it and go to surface properties, change the style to contours existing 1 and 5. And there's my contours, but I don't need to see all of this information like we did on the existing drainage area map. We only want to see the contours around the immediate site area. So I'll add a boundary. And you've done this before, where you use the endcopy command and pick on the property lines, glue property lines, and p-edit them together. Press enter 3 times. So I'll use the p-edit command. Yes, I want to turn it into one, and I'll join them together. This way, when I offset, it'll be just one object. It's okay to close this and escape. So there's my object, offset 50 feet to the outside. Erase the original so that you don't have the white line on top of your property line. You'd like to see your dashes on your property line. I'll assign this to the no plot layer. Whoops, there it is. No plot. And then under surfaces, expand existing ground, add a boundary, and we can say outside, or you can call it whatever you like. Outer boundary is fine, and it's an outer type, non-destructive. Pick it, and there it is. Okay, now we will go ahead and import the proposed surface, the proposed grading surface that the designer has completed. And as far as we're concerned, as entry-level technicians, our job is to make it appear and the way that we need it to, and to label it the way it needs to be labeled. So insert land XML, proposed grading. It's in the same folder as the previous surface was. We'll say OK. It also comes in, but it is an outline as well. So it is this one right here, this green outline. If I pick on that, it tells me that that's the proposed grading surface, and I now have two surfaces in my drawing. So with it selected, I will go to surface properties, and that's the proposed grading. Change this to contours proposed 1 and 5. We'll say OK. And so it shows up as green, and green for the minor contours, and cyan for the major contours. Now what we'll do real quick before I proceed is open the layer manager and going to change some layer colors for the proposed base geometry. So all of the XREF layers that are the proposed, so select the first one, shift select the last one, change the color to 8, which is a gray color, which is also a very thin line weight, except for the building. The XX base P building, we want that still to be blue, which is color number 5. So this will make it to where all of the line work in the drawing for the proposed base, the curbing, the sidewalks, islands, everything will be a thin line weight when it plots. The blue color for the building footprint will produce a bold line weight. So as you can see, all of the proposed geometry is gray. Now back to this proposed surface. If I pick on one of the contours, you can see that it's one object. And what we want to do is use the object viewer, and let's look at this in 3D. Just orbit that, and I'll change the visual style to conceptual, and you can see how the designer has created all of what is necessary for this parking lot. So starting with the building pad, it actually is flat right here. Remember in the front we said how the sidewalk would be flat right here in front of the building because there are some parking spaces, and there's 2 ramps right here. Well, there you go. And then here's the sidewalk that steps up. Sidewalk steps up. Actually, there's a ramp that comes up. Was not as accurate with the ramp itself, but nonetheless, it's here. And then here's a building pad. So you can see how the pad is flush right here where you're walking in from the parking lot. Walk right into the building pad, and the building pad is flat. Now since the ground, the proposed grade goes upwards in elevations toward the north end, then the building pad still stays flat. You can't have the building pad go up. So this is the building pad elevation is 734.3, so it's cutting into the exterior of the elevations around the outside. Then you got your islands. There's the dumpster pad in the back. There's the drive aisle back there. Here's our islands here. And we even have our curb openings. You can see those curb openings to allow for water to drain through, because we know the site is kind of tilted like this, so water is going to come and drain through there. If we didn't allow that curb opening, then it might get flooded. So the curb openings are along this way too. So for water that's flowing downhill this way, it'll have a chance to escape and come on around and fall into the pond. So we had these open curb openings here for water to drain in. And then obviously you can see the pond that has been modeled as well. And also here next to the pond we got the driveway connecting to the existing road. And on this southern edge of the pond, you can see that this is a quite steep area, and this is actually the retaining wall that is illustrated on your drawings by the 3 contour lines out front. So there you go. Okay, so that's the proposed model, and when you look at it from a top view, from a plan view, it's just contours, but when you look at it orbiting from 3D perspective, it looks like a 3D solid. So you know how to add contour labels to the existing ground surface. You want to use the annotate add labels dialog, where surface contour multiple or single, whatever you happen to need to work out, whatever the deal is, or at interval actually. So either of those will work, single, multiple, at interval, whatever you choose, whatever method, you need to make sure you use existing major labels. Okay, so if I'm using single, sometimes it switches on you, so instead of proposed, I want to choose existing major and existing minor. Click the add button, pick my surface, and then turn these off, and then pick my contour. So the existing contour should look gray with no border. Okay. Now, when you're going to annotate the proposed contours, you need to change your style setting to propose major and propose minor. Click add, pick your surface, and then pick your contour. So this will be the difference between annotating the existing and the proposed. So make sure they look like that. Look what happens if you don't do this. Let's say I'm trying to label my proposed and I choose existing styles. It just doesn't look right. These gray ones with no border are for the existing. Okay, so I need to erase those and replace those with proposed contours. So just place labels on every contour line. Make sure they're all labeled. You're going to have some within islands too that wrap around some portions of the islands. There's one there, there's some here. They're all green. So we made our proposed geometry gray from the proposed base so that we can see the green and cyan contours a little easier. And so as you can see, when you have a contour line, it starts at the existing ground and then it runs along the curb, comes across the parking lot. It's always finding its level line of elevation until it gets all the way around the building, and then it comes out this side and exits and ties to the other side. So this was all that one same contour elevation. So it almost follows the path of the existing ground, but until it gets to the proposed geometry of the building, then it goes around it, then around, and then back and ties in. Okay? So don't forget to change the styles when you add your labels. Now your spot elevations, we'll go back into the annotate, add labels, surface, spot elevation. Elevation only will be the label style. And when we click add, it's going to ask us to select a surface. Be sure that you absolutely select one of the proposed contours. That's your proposed surface. If you pick on the gray dash, that's your existing ground. You're not going to be putting spot elevations for the existing ground. You're putting spot elevations for the proposed surface. So be sure to select one of the green or cyan colored contours of the proposed. Easy way is just to pick on the detention pond. Now you'll select a point, so all of these points, or most of them anyway, snap to the corners, endpoints of the edge of pavement, and it produces a label for us. You don't have to type in any of the values. It's reading the elevation of the surface terrain where you click. For example, if you mistakenly click and you need to move a point, then you can just move the label, and notice when I reposition it, right now the value is 733.48. When I click a new position, it now updates the value of the label. So I'll move this back to the endpoint. And so you got various ones of these around the site, and add them where indicated on your example drawing. If you need to move a label to be clearer, then what you'll do is you'll pick it, and to move the label you select the square grip. That's the drag label grip, and you pick that, and then you can just move it around until it's in a more legible area. If you pick the other grip, the diamond grip, you're actually moving the object, so you don't want to do that. Choose the square grip, and now it's out here. So choose the square grip to move the actual label. Okay, and the next item is to import the drainage arrows. to indicate the flow of uh, rainwater travel along the top of the surface, the proposed surface. So it's kind of like the existing drainage area map. Um, so we'll go to Insert, Insert on the Insert command, and it's from your drop-down list, Drainage Arrow. You do want to specify the insertion point. So you just pick in the drawing where you want it to be, and then use your Rotate command to orient it properly. So remember, all proposed drainage flow goes perpendicular to the contours. There's a layer for this, and let's see where we put it. It's called Drainage Arrow. So be sure you put it on the correct layer. The arrow should be cyan, and so remember, there go perpendicular to the proposed contours. So just copy them on around and rotate as necessary. Okay, so use your example drawing as reference. And then your text boxes that you need to add, you'll go to the Annotate, Add Labels, their note for the feature is the note, label type is note, and the label style is text box. Click Add, and where you click in the drawing, for example, I want to label this, then I can drag it away by clicking on the square grip, and then click Edit Label Text and add your label, whatever is on the check print. I didn't populate everything on the text, but that's just what you'll do for the label. And then just remember to save your work as you continue to work along. Okay, so I'm going to close this, and on one of these labels, I can't remember if it's on the check print, but when you put the proposed building, be sure that you add the finished floor elevation, FFE equals 734.30, so that that is populated in the label. Okay, as far as setting up the layout tab, looks like mine's not being displayed, so let me turn mine on. When you start this drawing with the template, this time there's already a layout, and it already has the legend. So this might be the same thing that would happen at work, where the CAD manager may even, knowing that you would use a template to create a certain kind of drawing, they may standardize it even more by having a simple grading legend, or some kind of legend here noting what the objects are that are predominant on this plan. And it might even be filled out, proposed grading plan. You just, of course, would need to put in the name of it, but here is the drawing. So you want to make sure you set the appropriate scale, make it to position where you can see everything in the drawing. Notably, notice the top of the corner of the property line. Do a regen all, and everything resizes. And don't forget to lock your viewports so that you don't accidentally mess up the scale. And DDA-TTE command to complete the north arrow and bar scale information. Oh, not the north arrow, just the bar scale info. And on your page setup manager, make sure that your settings are for the civil plot style, plotting a DWF using a full bleed 11 by 17 size sheet of paper. And you'll print out your drawing and turn it in according to your instructions from your instructor. Okay, so that pretty much does it for this assignment. The beauty of this program that we have is in regards to a proposed surface is if we have a model like we did, we have this surface model, then you don't have to draw the contours. Have the model generate the contours for you. If you are working at a smaller company that does not have Civil 3D but uses regular AutoCAD, then what you would have to do is draw all of these contours by hand by using an offset command and trimming and extending and just creating them by hand, which can be, when you have a very complicated site with a lot of different elevations, it can be very tricky. And typically you'll get some kind of red line from the engineer or designer, and you just kind of draw with the polyline command where those contours are. But we had the designer create the model, and so then the model generates the contours for us, which is awesome. Okay, so that concludes this assignment and tutorial. Good luck.